Hi everyone, we're live, and just to ensure you can hear us, love it if you could share a question just to make sure we're not just talking out into the empty ether. Welcome everyone to our webinar, Runtime Security, 5 Ways to Reduce Application Risk. My name is Sandra Ware, and I'm the VP of Marketing at ActiveState. Today, I'm joined by an expert panel, and I'd like to extend a warm welcome to Jeff Rouse, VP Product from ActiveState, and Dana Crane, Product Marketing Manager from ActiveState. Jeff will delve into key considerations with security, especially when working in open source and CI/CD environments, as well as how to resolve tensions between stakeholders in the software development lifecycle. Dana will walk through 5 ways to reduce application risk, as well as a first chance to see a demo of our Runtime Security offering. This is the first feature set of our SaaS platform to build, secure, and manage open source runtimes. So as a reminder, we'll be having a demo, and at the end of the webinar, there will be an opportunity to participate in a Q&A. To kick us off, here's some context on why ActiveState is presenting on this topic. ActiveState provides a faster way to build and secure open source runtimes. We have over 20 years delivering commercial open source language distributions, and more than 2 million developers and 97% of Fortune 1000 companies use ActiveState open source language builds, including companies like CA, Cisco, PepsiCo, Lockheed Martin, and NASA. Our goal is to enable enterprises to keep up with coder innovation. We know firsthand some of the challenges with building, configuring, and managing open source languages. We eat our own dog food, so to speak, and live in a multi-language or polyglot environment. We build language distros for 5 languages, Perl, Tickle, Go, Ruby, and Python. And so we feel some of the same pains faced by today's enterprises, and we're passionate about solving them. Part of the solution is injecting security early on, as well as considering runtimes. And that's one of the key reasons for this webinar. We want to help companies get to market faster and maintain control of their security and compliance requirements. To start us off, I'm pleased to introduce Jeff Rouse, VP Product at ActiveState. JR oversees ActiveState's product strategy. He spent over 26 years in tech at companies ranging from startups to publicly traded companies, and in roles from team lead to project manager to VP development and services, and of course, as VP Product here at ActiveState. Welcome, JR.
Thanks, Sandra. So I'd like to thank everybody for joining us today. This should be a great discussion, and we're going to follow it up with a demo right at the end. First off, I'd like to give us a little bit of history to set the stage for our application risk discussion today. So we really need to understand how the current situation has evolved. So open source as a term turned 20 years old in February of this year. The actual watershed moment that created this incredible force that drives technology today evolved when Netscape, a software vendor at the time that was producing the first browsers, they decided to publicly provide all of their browser source code, and that was in 1998. And eventually, this led to the open and free software movements that eventually were battling it out against proprietary code bases, and ultimately, at least in most areas of software, open source has actually come out on top. As a result, the vast majority of all software created today either uses, is built with, or runs on a stack of open source software. These include operating systems, virtual machines, databases, web servers, language runtimes, and components within those languages. Almost all major languages today are open source. You can see major companies in here are both contributors to open source and use open source in the solutions they provide to their customers. For instance, Adobe, Facebook, Google, and even Microsoft, who is now actually the largest contributor to open source of any company in the world today. However, all of these companies have something in common. They realize that the strength of a decentralized mechanism to provide software actually provides a lot more power than just keeping it in a proprietary way. That's not to say that proprietary source code isn't valuable. Most companies are also doing their own thing as well. But it's really the power that open source has provided that has gotten us to where we are today. So developers love using open source to accelerate innovation. There is an incredible amount of reusable code to solve almost any problem. These reusable applications and software components are growing at an exponential rate, as you can see from some of the charts here. The largest of these, NPM, which is the package manager for the JavaScript ecosystem, is approaching the 500 million per day download mark. NPM is a bit of an extreme example, mind you, as JavaScript apps make extensive use of components, even down to modules that are actually only a few lines of code. However, across all of open source, downloads surpass the 1 billion per day mark. In addition, each day the supply of open source across all ecosystems increases by about 1,100 new projects and over 10,000 new versions of existing projects. These are really astonishing numbers. However, it means that these projects are effectively the Wild West. Because it is decentralized, who is looking out for your security and compliance needs? How do you use this incredible source of power to build value, but yet you have no assurances that it is a fit for your particular situation? The use of open source comes with great security responsibilities. Overall, security is a multifaceted topic, but today we want to focus on ensuring the open source code you are using to deliver value to your customers can meet your security and compliance needs. So here are a few items you need to address to be a responsible user of open source within your company. Know about any CVEs. CVEs are, these are threats that are in a public database. I'll actually identify exactly how those are categorized a little later on. Be aware of new threats. So threats evolve over time, so you need to be aware of new threats. New versions for the software components you're using. New versions in general are better, and statistics have borne this out. I know managing and fixing issues with versions and incompatibilities can contribute to delays and failures, but you can do this when you have control of the situation versus should a security issue arise. Understanding the dependencies. So each software component has its own set of dependencies, and there's dependencies throughout the whole stack that you use. And you also want to ensure that nothing gets added from the time where you specify what's going into your application to the time at which you put it into production. So I want to address some best practices here. Data will be going through the top 5 ways to ensure risk reduction, along with a demo a little bit later on, so stay tuned for that. But I want to break it down into just a few things that you can do immediately to help use your open source within your organization. First of all, start early. So this is the classic DevOps flow diagram. Get as much information into the hands of the developers you can at the time they are designing and writing the code. Don't wait to figure out the attributes of the components you are using later on in the cycle. This leads to delay and unnecessary work. For instance, you need to understand the licensing, dependencies, compatibilities, project health, and CVE threats of the components you're using. It's very important for operations to also get feedback back to the development team in a timely fashion, so any security and compliance issues can be addressed. You need to keep up to date. Allowing your software components to lag behind is asking for trouble and leads to considerable buildup of technical debt. Software must be maintained, and staying current on versions is key to remaining secure and keeping that technical debt in check. Regular monitoring of new threats. So CVEs are known as common vulnerabilities and exposures. That's a standard way to convey information about security issues for software components. You must maintain active monitoring for all the components you have as CVEs emerge over time. A one-time scan or hoping you'll hear about it if it's a big deal is poor practice and should be addressed proactively. This is a key part of any security monitoring. It can be part of your DevSecOps practice. It can be part of a DevOps situation, but no matter what, your company needs to address how you actually monitor the situation. And you need to understand your risks. Not all risks are created equal. Each risk must be evaluated on its own merits. So each CVE is categorized by its severity. The most severe CVEs are the ones that are remotely exploitable or that are very easy to exploit. Rather, they usually don't require permissions or have a way to get root on a system or anything like that. Those are the ones that you have to be most concerned about. Then there's medium risk ones and lower risk ones. But so you need to understand what it means, and in particular, what it means in your situation. So if you've got very sensitive data, then you need to be doubly sure of it. And just to be clear, security is a multifaceted thing. You know, software components are not just the entire story, right? It's one element, but it's a very, very important element for application development. And lastly, less is more. Don't pull in too many unnecessary components. Keep your attack surface as small as possible. Be diligent about refactoring and removing old code and components. Again, this is also addressing technical debt, but it's also addressing proper security measures. These elements are very important, and I'm hopeful that if you aren't doing them already, that you'll take this to heart with some best practices for your team. Now, I'd like to go into the future. The future of application development is providing organizations with the ability to deliver innovative applications to market faster without losing control over the things that matter, namely security and compliance. These are all known issues, and organizations should not have to roll their own solutions in order to take advantage of open source. One of the key trade-offs in any software project is checking all the security checkboxes versus doing the bare minimum so you can get your product in the hands of your salespeople or key customers faster. Obviously, the more time you take to stack your application up against all your security controls, the more solid your application will be, but the longer it'll take to get to market, increasing the potential to miss market opportunities. Skipping selected security controls results in faster times to market, but it also dramatically increases risk that you've released an application with security holes. Again, you have to evaluate all of your risks based on your particular situation, but the key is to actually do the evaluation so you know what to do. One of the key trade-offs in any software project is checking all these checkboxes on security versus doing the bare minimum. You really want to ensure that all of your software can actually be properly vetted in each of the stages that are outlined on this slide. ActiveState provides security and compliance visibility for all stakeholders across the entire software development lifecycle. Everyone can report on security and compliance issues whenever the application is run, including production, thereby eliminating blind spots. Identifying unrecognized packages that may be custom code or modified open source packages, and verifying that production applications match non-production applications, ensuring changes are not being made directly to production, right? It's really important to ensure that what you think is there is actually what is there. The ActiveState platform really allows you to track issues as they arise. The key technology driving a lot of this is technology we have that is not unlike software composition analysis, but it ensures that it empowers developers and ops personnel. It provides security and compliance visibility for all your stakeholders across your entire software development lifecycle. The ActiveState platform allows you to track issues as they arise in real time. The key technology driving the security and compliance features of the ActiveState platform is our Python interpreter plugin, which collects security and compliance information about the application at runtime, wherever the code is executed, without the overhead of an agent. Unlike agents that run continuously, the ActiveState plugin runs only once when a new package is loaded. This usually takes less than a second at application startup and a few milliseconds for each new package that's loaded thereafter. Only the package name, version, and license information is sent to the ActiveState platform, which is running in AWS. A real-time snapshot of package vulnerabilities, licenses, and dated components are tracked on the server, and you can get alerts to these over time. And with that, I'd like to pass it back to Sandra, and we'll continue on with Dana and the rest of the webinar.
Thanks so much, JR. Sounds like you've got quite a bit of passion about this topic and even some firsthand experience in juggling speed and control. So really looking forward to the Q&A at the end of the panel. As a reminder to everyone, we will be having a Q&A session at the end, so you can start submitting your questions as soon as you'd like. I'd now like to introduce our next panelist, Dana Crane. He's responsible for the go-to-market function at ActiveState. Dana has over 20 years of experience crossing and falling into, as he says, the chasm, as well as capitalizing on and being disrupted by innovation. Welcome, Dana.
Thanks, Sandra. So I'm going to get started and just dive into these 5 ways to reduce your application security. I'm going to start with number 5, and that's a really, not an application risk, but it's really more talking towards your culture. So if you think of what dev versus security looks like, dev being primarily concerned with speed and creativity, and security being concerned with thoroughness and control, that kind of culture clash can result in a lot of tension, and some of that tension can translate into a lack of trust. So if you think of the kinds of best practices that security lays down and maybe the corners that dev cuts when they're trying to get to market quicker, that's where that lack of trust can start to bubble up and become an issue within your organization. One of the ways that you can deal with trust is by introducing transparency, and that's something that the ActiveState platform allows you to do. One of the things that we allow you to do is, if you're a developer, you can use that plug-in, plug that into your code base, and then push that information up into a centralized server. Now your security team can, at any point during your life cycle, whether you're developing, whether you're testing, whether you're going through your CI/CD chain, or even when you're in production, those security guys can now go in out of band without bothering you, go in and check that you are indeed following those best practices that they've laid down. They can check all those package licenses. They can see when CVEs or vulnerabilities get addressed. And that can be sort of the trust but verify mechanism. They can verify that you are indeed following those best practices throughout that software development lifecycle and resolving any issues appropriately before we get to production. And it's this kind of common tooling that, when you put in place, makes for common teams with common goals, and that's really what you're trying to do in your organization. It's all about getting that application securely and in compliance with your corporate policies to market quicker. Number 4, this talks about testing. So when you think about testing, everybody does this. You've got 2 sets of kinds of tests. One is ad hoc, the other is systematic. And you may apply one or the other at different points during your sprint, wherever it makes sense. So, which is great, but these 2 different methods have their own drawbacks and their own benefits. So if you think of ad hoc testing is terrific when you're trying to release quickly, you're getting towards the end of your sprint, maybe you only pick a single process, typically the critical path, something that if something's going to break, you're going to see it in that critical path. So you're testing that one single process straight through your application, and you're ignoring all the others. Or maybe another ad hoc test might be just a partial scan. So instead of doing a full scan, you're just running a partial scan, typically only on code that's changed. And now, you're probably ignoring those results. You've got this whole thing automated. So if there's a critical warning, that's going to trip a flag, and you'll fail that build, and you'll go back. But typically what we're just looking for is a pass-fail here, so you can get this off your plate and start pushing this out into production as quickly as possible. So that's a great way of applying an ad hoc test, but in some cases, you want to also use your systematic testing processes as well. And this can be at the beginning of the sprint when you're just introducing new code, and you feel more comfortable when you're running a full scan and trying to see what's broken, what may not have passed some of the flags. So one of the other key considerations here is that some organizations are stuck. They're always running full scans, and that might just be corporate policy, or that might be industry regulation, but they're stuck to always run full scans. And if those scans have to be run synchronously, in other words, they can't be run asynchronously, that can really slow down your time to market. And typically with a full scan, you're going to be looking at all of the results that come back from it. So you're not just looking for critical warnings, you're looking for severe as well. And as soon as you start digging into those severe warnings, you might suddenly realize there needs to be something that needs to be fixed, which is going to trip another remediation cycle, which again is going to slow down your time to market. So all in all, these kinds of things need to be applied, they need to be gone through, but it can really slow down your time to market, or you can push things out quicker, but again, you won't have that surety around the security of that application you're pushing out into production. So one of the ways that the Active State platform can help here is that once you put the plugin into your application, now we're collecting information across that entire software development lifecycle. So wherever your code is run, your CI/CD chain, we're capturing that information, making it available on the central server so that all of the stakeholders across your entire organization can log in and get a view of what's happening here. So in other words, all of these tests are being run out of band. None of them are throwing up roadblocks. If you want to dig in and look at the report in detail, you can. You're not going to be slowing anything down. Everything's running asynchronously in the background so that by the time you're ready to push to production, you've got everybody on the same page and everybody's gone to the level of depth that they need to feel sure that what you're putting into production is both secure and compliant. Number 3 talks about security itself. So if we think about the old days, back in the old waterfall days, I hope there's a few other long in the tooth people on the webinar that can remember these days. But back in the old days when we used to take 6, 9, 12 months to get to market, security could follow that entire process and have the luxury of time to plan what they wanted to do with that application, what kind of bolts they wanted to turn, what kind of screws they had to put in place to make sure that the application was going to be secure by the time it got to market. And they had a long, long leeway to put that plan into place so that they could be very assured that the regimen they were putting in place was going to nail down any of the loose ends that may have been lost during that development cycle. But in today's environment where everything is agile and you're pushing code into production on a weekly basis or maybe even an hourly basis, there isn't that luxury of time anymore. So that sort of bolt-on security is just not going to scale. And when you think about it, there's a lot of research out there that says 80% of security issues all happen before the first line of code gets written. That means trying to bolt on security afterwards is like buying fire insurance after your house is already burned down. So one of the ways that Active State can help here is, what we've talked about before. We've got 20 years worth of experience building open source language distributions. And that means that we're going to take on that kind of security and compliance verification for you. We're going to resolve all those dependencies. We're going to apply all the patches, make sure that nothing is coming in with a vulnerability. And we're going to give you a standard package that you can then deploy to all of your developers' desktops. Now, when you standardize, that means that for your CI/CD routines and when you're building those environments, everybody's comfortable because you've got the same package on every developer's desk. That means less failures in your integration build and more smooth way to get to market, get the thing through your CI/CD chain faster and into production. But we all know that even though you have a standard distribution on developers' desktops, a standard development environment, developers are still going to go out and add in their own packages to try and solve problems. So that's where the Active State platform comes in. Now, even though I've standardized on a certain package, I know that things are going to get added over time. But I can use that platform to examine which new packages are being added, something that might be outside of the scope of what we standardized on. I can check those brand new packages for licenses. I can check them for security audit. So I can be assured that by the time we start doing an integration build, everybody's already on the same page. They've accepted that something new has been added and it's already been vetted before we start the build. So again, better ways to bake in security, make sure everybody's on the same page before we start even coding line 1. Did I skip one? Number 2. So number 2 talks about really triaging and prioritizing. So when we think of what's running and what's not, what we're really talking about here is which of my packages in my Python application are running in production and which are not. Now we all know that packages get added over time, clutter sort of builds up, things that you put into your development build that were just basically testing out new features, testing out new functionality, seeing if you could solve a problem. That didn't really work out, but you didn't take the time to remove those packages. Or maybe there's a bunch of test harnesses here or some code linting packages, things that help you through that test cycle, but we don't really need them in production. So those are things, or even features that get removed. So sometimes you have to get to market quickly. You thought you'd get a feature in, but didn't quite work. It got cut at the last minute. You don't want to rebuild and remove those things because you're going to get to them in the next sprint. So that might actually go through. So there's lots of packages that might end up in production that are there as part of the build, but they don't actually get run. And that again is where the active state platform comes in. Now you can tell exactly which packages are being run in production. So this gives your InfoSec team a little bit of an advantage here. Now they can go in and understand that, hey, this application might be composed of 100 packages, but actually only 80 of them ever get run. Now you can start thinking, when I triage issues, I can start thinking about, if it's in one of those 20 packages that never gets run, perhaps I can deprioritize that. Now, that might not be possible according to your corporate policy, but in some cases that may provide key information that could free up time, free up resources. I don't need to go to the nth degree on some of these packages if they're not being run. I could ignore them for now and prioritize others that need to be fixed. And then finally, number 1, talking about compliance and license risk. So this isn't really application risk. When we think about compliance, when we think about licenses, what we're really talking about here is thinking about corporate risk. So if you're like most organizations, what happens is once a year, the audit team or the compliance team or the risk management team, it could be called different things in your organization, they get together and they create this yearly audit. And they go through all the applications that are running in production, and they look at all those packages, and they look at how they're licensed, and they make sure that what you're running is compliant with what your corporate policies are. And invariably, they'll find 1 or 2 things that are out of compliance. Either something's been modified that wasn't in compliance with the license that that package was licensed under, or maybe you're actually running GPL code or LGPL code, which are usually forbidden in organizations, and something just slipped through. Well, now you've got something that's been running out there in production for maybe as long as 12 months, and that really is going to increase that corporate risk that you could be caught out doing this. So license checking needs to become more than just a yearly event. It should be something that goes on as part of the regular development cycle. One of the ways that Active State Platform can help with that is that, again, because you put that plug-in early, you've got that information for each and every one of those packages that you're running across all of your applications across your entire extended enterprise. They're always available for that compliance team to go and take a look at. One of the other great ways that the Active State Platform helps is that we flag unrecognized packages. Now, when an unrecognized package is flagged by the Active State Platform, that could mean it's just custom code. Somebody's built a module to do some function, and it's just custom code that you've built. But in other cases, it could actually be an open source package that you've made a modification to. And being able to flag that gives that compliance officer a way to sort of dig into that code and understand if those changes were made in compliance with that license of the package. So again, great ways for the auditing team to be able to track your application licenses across that entire software development team and decrease that corporate risk. And talking about auditing, here's a little bonus. One of the things that we can do for those auditing teams is help them understand whether changes are being made in production. Now, in any modern software company, nobody's going to have developers jumping into the production side and making modifications to code that's actually deployed. You're always going to want to go back through your software development life cycle, through your dev and test cycle, and then push out that change back into production. But in some cases, this could happen. When that rollback button doesn't work and you've got an outage, sometimes you're going to make a call whether it needs to go back through the software development lifecycle or whether you're going to start mucking around with code in production. One of the best ways for an auditor to be able to be sure that nothing is being changed in production is to be able to use the Active State Platform. The Active State Platform gives you a snapshot of all of the code that's in your non-production cycles, and you can use it to compare visually against the footprint of that application that's running in production. So in this way, the auditor has a very simple, easy, visual way to make sure that if your non-production code looks like a duck and quacks like a duck, your production code does so too. And I think that's it for our slides. I'm going to jump into the demo and give you guys a first-hand look at what our platform looks like. I'm just going to boot up my browser here, and I'll start by signing out. So here I am at platform.activestate.com, and I'm going to go ahead and log in. And once I log in, it's going to bring me into my dashboard where I see that I belong to two organizations. You can see I belong to the Active State organization, and that's really just our production applications that are running across our enterprise here. And I also belong to a pizza team. And this is me being a developer contributing with a couple of other guys to a brand new application that we're currently building. So I've got a way to join multiple organizations as the same entity and be able to get a look in at the different ways that applications are being managed across our organization. So let me just jump into the Active State organization. And you can see my dashboard loads here, which gives me a look in at what's been happening with those applications on the platform. This is usually recent information. Some of this is kind of out of date, it's 21 days ago, but it gives me an idea of what's happening with those applications on the platform. And you can also see over here that there's a bunch of members. In fact, there's JR, he's the owner of this organization, and he was the one that invited me in. It's just an email invite, I signed up. And he can also manage any of the people who are here. So if somebody leaves the organization, he can remove them as well. In the middle, I have the security and compliance tab, and that's where all the magic happens. Now, on the summary tab, what I'm looking at is a cross-section of all of what we call identities. Now, identities are really just application instances. For instance, you might have an instance of your application that's in development. You might have one that's in test. You might have one that's in production. In this case, these are all applications just running in production. You can see that I'm tracking out-of-date packages. So this is actually tracking all of the packages for all of the applications across the entire enterprise. So I'm getting a look in at everything. It's giving me a great overview. And it's also giving me an overview of all the warnings that crop up for all my applications as well. I can drill in here and see which applications have these warnings so I can get a better look. I'm going to save that a little for later. But what I really want to talk about is how would I get started here? If I wanted to upload an application to this dashboard and track it over time, how would that happen? Well, we have a getting started area. I'll click on that, and you can see the first step is just to download the plugin. So this is just a Python package that you pip install, and it just installs into your interpreter. And this is what's going to collect all that information that allows us to determine if those packages are out of date or if there's a vulnerability against one of those packages, that sort of thing. And I can create an identity, which is really just a configuration file. So if I go ahead and click the Manage Identities button, I can create a new one, called a new one. And I'll click to create. And what you can see is I'm generated a unique identifier for my application instance. This is my instance called new one. It's going to send all this information up to platform.activestate.com, and I've got some interesting options of how to deploy this. So I could deploy this directly within my directory that I'm running the application from. That way I can track the individual application, or I can deploy it in my home directory if I want to monitor everything running on my computer, for example. There's different ways to set up this configuration file in order to do different things, report different ways. It depends on how you want to get that done. So that's sort of the overview. Let's go ahead and drill in on one specific application, and I'm going to join the pizza team at this point. So the pizza team is just me and a few other people, and what we're doing is we're working on one application. It's not live right now. As you can see, I don't have any active identities. But if I go ahead and view all on this, you can see I've got a MyAppDev, a MyAppTest, and a MyAppProd. So it's basically just 3 different instances of the same application that I'm tracking through dev, test, and production here. And what you can see is I've got 3 medium severity bugs against my MyAppDev instance. So if I click on MyAppDev, let's go ahead and drill in, and you can see that those warnings are all associated with the Django package 1.11.8. But you can also see, if I could go back for a second, that we've resolved that in prod and in test. So if I think of what we've done, if I click on the prod instance, what we've done is we've gotten rid of Django and we've used Flask instead. So you can see Flask is all the way through here. We've just removed Django because it had a thread around it. We could have updated the library maybe, but we've made the decision just to remove it. So now, if I'm an auditor and I'm looking at best practices, I can see what's happened, how that application has evolved, what we've done to resolve that vulnerability. So that gives me a little bit of a look into that whole development lifecycle. One of the other key things to think about here is we're tracking components. So we're tracking those packages over time. You can see in development, I've got 41 packages. Over here in test, I've reduced that to 26 packages, so maybe 15 packages I pulled in here, did a little bit of experiment with, didn't think they were very good, so didn't actually include them in my build. And by the time we get to production, I've only got 22 packages. So you can see that maybe by the time I wanted to roll this out in production, what I've done is I've actually reduced the number of packages, reduced that footprint, and therefore reduced the attack surface, making my application more secure. Again, if I'm an auditor and I'm looking through this, I can see best practices being followed here. I can see how the application has evolved over time, and I can see how it's getting more secure over time. This all gives me really good feeling that I can track this application and how it's going to market. One of the other things I can see here is that, I see 25 out of 26 components are recognized. Well, if I'm a compliance guy and I see that, I'm thinking, well, what is that one component that's not recognized? What I can do is I can drill into my app test, and I can see all the components associated with it. If I scroll down a little bit here, I can see one component that's not recognized, this one, pigment 220. And I think, well, what's wrong with that? And I click on that and I can drill in again. What I can get is a little profile. I can see that no license information found. That gives me a clue. So now I can understand maybe somebody's gone in there, maybe somebody's modified the code. When they're modifying the code, maybe they deleted the license information from it. That could have happened. So now I've got a point of entry. Now I've got some place that I can sort of drill in, take a look, see what's happening here. So I'm enabling my dev team, I'm enabling my security team, I'm enabling my compliance and audit team. They've all got to look in. Nobody's disrupting my dev, test, production cycle. Everything is moving along. This is all being done at a band. All the stakeholders have great information to be able to pursue what they need to pursue out of the band without slowing me down. So that essentially is the gist of the whole platform. And I'll throw it back to the slides again. Sandra?
Great. Thanks a lot, Dana. We're now jumping into the Q&A session of the webinar. So I'm going to jump right to the first question. I see from your website that you guys support languages like Perl and Go and Ruby, but you only seem to be talking about Python. Does your platform support other languages or your other languages you have right now? What about Node or Java?
Sure. So the platform currently supports those languages, as you've mentioned. We are looking very closely at Node being the next language we add to the platform, and Java is potentially a little further out than that. But Node, as you saw from the presentation, can really use some help in this area because just the way that language ecosystem is. So Node is next up for us.
Yeah, one of the key things to think about right now is that our plugin works with Python at the moment, but as JR alluded, all the things that we support today are things that we're going to be supporting with the platform.
Great. Next question is, it sounds like you guys would do a lot of the same things that our Black Duck scan does for us. How is your platform different? JR, do you want to take that one off?
Sure, I'll take that one on. So like any of the scanning tools that are out there, they're all using publicly available security databases. So we use a variety of those, including the actual managers from the language ecosystem. So we access PyPI, for instance, to get our Python information. So it's a blend of things, but the main thing for us is that we actually provide you the knowledge at runtime, whereas a lot of these other products like Black Duck, you have to statically scan at some point in your development lifecycle, but that doesn't necessarily mean that what you've scanned at that point in time is actually what ends up in production.
Yeah, I'll just add to that, that's sort of the snapshot in time that these scans give you, whereas we give you that 360-degree view all the way through your life cycle. So if that's important to you, and that could be important for, say, an audit person who wants to see that you're adhering to those best practices, this can be a really good way of being able to visually show how that scan has evolved through your life cycle.
Great, thanks, JR and Dana. Next one's a little more specific in terms of Python. What versions of Python does your platform work with? JR?
Sure, absolutely. So our interpreter technology actually works with either the 2 series or the 3 series of Python. So there's no issues there, regardless of the version you're on, whether it's a 2.7.13 or 2.7.14, or whether you're on 3.4, 3.5, 3.6, 3.7 is almost out the door here. They're in the final beta. It'll work with any of those.
Enough of that.
Okay, great. So this one is about containers. We deploy using Docker containers. Can your platform scan for security and compliance inside of containers, JR?
Yeah, so because our technology is actually used at runtime, wherever that interpreter is running, whether it be a Docker container or a virtual machine or your local desktop, it'll work wherever it is.
Great. Okay. Then what about some of the specifics that you covered in terms of the demo? Where do you get the data from the Python, what's on the Python packages?
I think JR alluded to this a little bit. We connect to the actual source. So in this case, we're looking at Python applications, so that would be the Python package index. But we're also grabbing a lot of the security and vulnerability information from things like the publicly available NVD, National Vulnerability Database. We're also pulling it off of social media sources. We're getting it from dev resources like Stack Overflow. Things like that are being pulled in so that we can catch these things early.
Yeah, absolutely. The only other thing I want to add there is for some of these languages where we've really specialized in over a long period of time, we're actually involved with the security teams on those core languages. So we get advanced notice of a lot of security bugs when they're coming down the pipe. So that also is something that impacts the platform.
Great. Okay. Next question is, how long does it take to configure to get this running for my application? So the steps 1 to 3 kind of thing. JR?
Sure. So it's really quick to get running. Dana went through the steps there. I mean, it's a tiny plugin. It's 1 command to install, and it's literally cut and paste the configuration file, place it within your home directory, or I mean, it depends on the platform where you're dropping it, where you want to put it. But ultimately, I mean, you can probably get this running in 1 to 2 minutes tops. Like it's really quick.
Yeah, it's super easy. There's no pain, no fuss, no muss. It's very, very simple. There's absolutely no reason why you couldn't do this for all your applications at any point in the cycle. That's sort of the key to making sure that this is transparent, easy, simple for all of your stakeholders to be able to get that information. The barrier to entry is very, 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 very low.
Okay, great. Now, what about getting up and running with this? We've talked about how the product works, where the future is in terms of what we're trying to solve. But if I'm somebody who's interested in using this, how do I get up and running and get on the platform? Dana, maybe you want to tackle that one first?
Yeah, well, one of the things that we're making this available to is our Python Enterprise Edition customers. So if you're a Python customer of ours today, if you've standardized on the Active State Python package, this is very simple and easy for you to get on board. All you need to do is give us a call and, or even just visit our website and download the Python runtime from us, and that'll get you started to begin with. Our sales guys can then set you up with a sort of prototype that you can go ahead and log in and get started, test this thing out for yourself and see how it works.
Yep, that's great.
Great. I think that brings us to the end of our questions, so we're able to finish up that session a little bit earlier, which also brings us to the end of our webinar. So I want to thank our panelists once again. My colleague is Jeff Rouse from Active State, VP Product, and Dana Crane, Product Marketing Manager. And if you're interested in using the platform and joining millions of developers and Fortune 1000 companies that benefit from our open source language expertise, because we've been at this for a little bit of time, over 20 years, please email us at platform@activestate.com. And as Dana mentioned, you'd also can try out our Python builds, free to download at activestate.com/activepython. And thanks to everyone for attending today. We've got some additional contact information there should you need it. And everyone who's registered will be receiving a copy of the webinar. I hope everyone found this useful and have a great rest of your day.